So in true Apple fashion, Apple has been dropping major releases one after another over the past week. Already, they've sold out of pre-orders for the Apple Vision Pro. They've presented some insane new demos for AI and VR and how they can work together with a lot of Apple technology wrapped around that. And again, Apple is just hammering wins on the daily with the release of even more open source AIM models. So basically, this is a set of scalable pre-trained large image models that make everything that Apple does even more powerful. And we also have some interesting new updates with MLX, their groundbreaking ML platform, which is still technically in beta, that makes everything run incredibly fast from the LLM world on Apple Silicon. So welcome to AI Flux, let's get into it. So Apple didn't just release one model, they actually released 5 of them. They've released Apple AIM-600M, 1 billion, 3 billion, 7 billion, and just the generalized model Apple AIM. And they've also finally released the paper to go with these. So basically you can understand roughly how these work, but they haven't really told us how to run them on our own hardware yet. Maybe we'll get that soon. And the question is, what are these models? Like, have we seen these before? Have we heard of them before? How does this all work? So we actually have heard of these before. Apple did hint at these in some of their AI talks at WWDC just a few months ago. They didn't give us really any information about them. They pretty much said they were just working on these. And what I like about these is Apple doesn't go first with big demos and then explain how things work later. They're kind of building in the open somewhere between Meta and a lot of these other AI companies like Rabbit. And for instance, Rabbit has not shown anyone their model yet, other than the fact that we know Perplexity kind of plays into it somehow. But what I like about this is continuing to grow the developer space around Apple and further strengthen their grounding in tooling, which is how you get the best content on your platform. And I don't think they're just going for mobile devices. I think now with the release of the Apple Vision Pro, we know that AI and specifically image classification and the kind of 3D wrappers around that are going to play a huge role in what they're calling their Vision OS and spatial computing, or spatial AI, which is a really curious combination of a bunch of existing AI technologies and new VR technologies. And to be frank, I'm not really a huge fan of VR stuff. I don't like the idea of working in it. MKBHD made huge waves when he said that he likes VR, but although he's probably spent more time in the Apple Vision Pro than any other person on YouTube, he actually still doesn't really like wearing the headset for more than a few minutes, which I find interesting given he's said that that hardware is the best in existence. So what are these models all about? The technical term for these models, as Apple tells us, are scalable pre-training of large autoregressive image models. Now, there are a lot of big words there, but I'm going to try to break this down into something that all of you, not just developers, can understand. So from the abstract, it says this. This paper introduces AIM, a collection of vision models pre-trained with an autoregressive objective. These models are inspired by their textual counterparts, for example, large language models, and exhibit similar scaling properties. Specifically, we highlight 2 key findings. 1, the performance of the visual features scale with both the model capacity and the quantity of data, which is a big deal. 2, the value of the objective function correlates with the performance of the model on downstream tasks. We illustrate the practical implication of these findings by pre-training a 7 billion parameter AIM on 2 billion images. And basically, they probably just picked 7 billion because it's a really popular size for these open source models right now. That achieves 84% on ImageNet 1K, with a frozen trunk. So that's basically a really common benchmark for image models. Interestingly, even at this scale, we observe no sign of saturation in performance, suggesting that AIM potentially represents a new frontier for training large-scale vision models. And to be frank, this has been an area where, like, you know, the idea that you have more data and that you can just throw more data at these models has been kind of a sticking point and a wall people haven't gotten past for some time. The pre-training of AIM is similar to the pre-training of LLMs and does not require any image-specific strategy to stabilize the training at scale. So for those of you who don't know, previously the way we thought we had to do this was to find curious ways of increasing the amount of inference that could happen. So by limiting the number of examples you had to provide, or by deliberately scaling down and obfuscating inputs so that the model has to think a bit more, and then tricking it into using kind of less data to get better results. Problem with that is that you get what they've said here, where like saturations on areas of expertise, or it will start to think a lot of things are actually something else because the scope of the image training set wasn't big enough. So generalizing image models is actually much harder than generalizing large language models. And it's cool to see that Apple is focusing on this and is willing to share some of their approach here. And they kind of show it here. So basically right now, the biggest model they've shown is a 7 billion parameter model. And I think they did this because in theory, this would be a model you could right now, or maybe with the next generation of Apple Silicon, run on an iPhone or the same Apple Silicon that's in an Apple Vision Pro. So you'll see here that the latency across 15 benchmarks is presented here. So we start with a sub 1 billion parameter model, a 1 billion parameter model, a 3 billion parameter model, and then they show that you're getting basically a 1 point something % bump when you go from 3 billion to 7 billion. And I'll find some examples I'll link below in the description, but before this model was released, there were some attempts at this, but near linear scaling or better than linear scaling, as they've shown here, is not common in image models. And you might wonder, okay, so what is Apple actually doing with these image models? Frankly, there are probably some of these already on your iPhone that are doing facial recognition or trying to classify your photos on your phone. The other thing is, especially when it comes to segmentation and when it comes to understanding what to focus on, there is a ton of compute going into the Apple Vision Pro with all of its cameras looking around to understand where you are physically, understand what objects in front of you are, and helping to understand just what you're looking at and how things should be placed. Understanding depth is also a really big factor here because obviously if something is closer up, you're getting more context and you're much more likely to be able to identify that. Curiously, there's some depth models that rely on this. A big thing here is they're also very open to this idea of pre-training. And what's cool is they introduced this idea of something called a prefix casual transformer, which most of the modern models we see today in LLMs are built on transformers. Mamba is a departure from this that we're going to make some more videos on. I think it's pretty interesting, but these all use transformers still. And they pretty much show here that they use a kind of clever tiling approach. So the idea here is input images are split into non-overlapping patches and embedded linearly. The patch features are fed to a transformer in which the self-attention operation is casually masked to prevent attending to preceding positions. Afterward, a heavily parameterized MLP processes each of the patch features independently and finally projects it to pixel space. The targets correspond to the input sequence shifted one position to the left, requiring the model to predict the next patch in raster order. So what's cool here is those are basically a lot of big words to say that Apple is applying some really curious graphical programming techniques to training ML, which I think is kind of cool. And it sort of makes sense because rasterizing is a really common process GPUs use to parallelize actions. And they're not really using it to parallelize what's going on here. They're using it to give it a better understanding of what should come next in the next pixel. And this is likely what's giving kind of some large speed ups here. At least my friends who are more on the research end of things, this is a big thing that they've emphasized with this paper. And I am going to link to another video that gets much more deep into this and takes a more academic approach. It's basically from a channel that just reviews archive papers. And you can actually look at all this on Hugging Face right now as well. And the community actually has some pretty interesting prompts here, along with some recently added advice for how to actually run this locally, which was only added 13 hours ago, which is pretty cool. So I think it's really cool to start to see some of this technology on the AI side being released, not just from Apple, but because it's vision focused, which is a much harder problem than LLMs in my opinion. It's not really, multimodal per se, but image models are really hard, and it's cool to see Apple focusing on these. I also think it is super underrated that people are not talking enough about these models being integrated into Apple Vision Pro, and that VR really is going to start leveraging a ton of AI stuff very, very soon. It's just, there's been a long roll up to it, and Meta has been careful to pick their words when they talk about their work, because in reality, the reason Meta is coming out with all this crazy AI stuff is it was a clever way to tell investors that they didn't mess up doing metaverse stuff, and that the metaverse was kind of the first try. And curiously, the biggest missing part of the metaverse at Meta was AI stuff, right? Like the idea you would have humans generating or just procedurally generating scenes and things to interact with, that was the one missing piece. And again, I'm not still a huge fan of the metaverse. I like being in person with people, but yeah, the space is about to get very, very interesting, and it's really cool to see this coming from Apple. Now, I mentioned I was going to talk about MLX. So MLX is another big part of this, right? Because MLX is something that allows you to basically run transformers a lot faster on Apple Silicon. And there's some people who are saying that MLX is kind of a rug waiting to be pulled on developers. And frankly, I don't agree with this. It's important to mention that a lot of times when Apple releases research, it's sort of up in the air. And you have to think about why they're doing it, right? So Apple, I think, is doing this knowing they're kind of at a loss for their advantage in terms of keeping stuff secret, but by open sourcing this, it shows that Apple Silicon is a great platform to develop on. Now, yes, MLX does come with a pretty restrictive license, and no one is blind to this. And there's a question of how much continuous work is actually going to go on with MLX. And some argue, oh, well, since that's the case, what team is actually working on this? Is this just getting passed around? And I would say that Apple's intent with putting this out is to basically sit back and watch and see what developers do with it to understand what the direction inside Apple with MLX or the next iteration of MLX should be. And honestly, I can't wait to see what that is. I've been messing around with MLX. It's crazy the performance gains this even gives you if you're running like an M1 Max from now like 2 years ago. And I think it's going to be really exciting to see. So if you want to see sort of some more in-depth videos on this kind of content, please let me know. If you liked our video and you learned something, please like, subscribe, and share our content. It helps us out a ton. And we'll see you in the next one.